Hi, welcome to my today's presentation. The title of my today's presentation is a data-driven shunt dispatch approach to enhance power system resiliency against windstorm. Motivation and proposed approach. We know that the frequency of power system outages due to extreme weather events is increasing. Therefore, we need to develop power system resiliency enhancement methods. The computational burden of existing analytical power system resiliency enhancement methods are increasing with increase in the dimensionality and uncertainties of modern power grids. Therefore, in this project, we have developed a data-driven, deep reinforcement learning-based method to enhance power system resiliency using shunt resources. At the beginning of this project, we have constructed a multi-agent framework using soft actor critic algorithm. Then we trained the developed multi-agent framework to enhance power system resiliency using shunt resources. At the beginning of a training episode, we select candidate lines randomly and then we create contingency scenarios based on the fragility curve. Then we run power flow and check system states, and the agents provide action if based on the system states. The actions are nothing but shunt sizes. Then we implement the actions and run power flow again and check new states. If the voltage violation shunts are not resolved, then we check the number of iteration. If the number of iteration is less than the total number of iteration of a training episode, then it moves to the next iteration where the agents alter their actions and the new actions are implemented and run the power flow and check the new states. If the voltage violations are resolved or the number of iteration of a training episode is equal to the total number of iteration of the respective episode, then it calculates the rewards or penalty and move to the next step. Following this approach, the agents get trained and eventually provide accurate action to enhance power system resiliency. We have applied our proposed approach on a modified IEEE 30 bus system. Um, we assume a windstorm is passing through the system, which is shown in the figure, and for assessment purpose, we have considered 5 shunt compensators which are installed at bus 3, 7, 11, 18, and 27. We have checked the voltage violations for 2 different scenarios, which are with agents and without agents. Also, we checked the training performance of the proposed multi-agent framework, and from the figure we can see as the multi-agent framework explores more scenarios, the action time decreases and the reward value increases, which indicates the agents get trained to resolve the outage scenarios quickly using shunt resources, which means the power system resiliency is increased. And also we checked the performance of the trained agents for several scenarios, and we can see that the trained agent can resolve most of the outage scenarios. Also, it is worth mentioning here that the trained agent cannot solve a couple of outage scenarios, which is not surprising because shunts alone cannot maintain voltage magnitude within limits. Here are several concluding remarks. The proposed multi-agent framework was demonstrated on a modified IEEE 30 bus system. The results showed that the multi-agent framework can maintain voltage magnitude at system buses within limits for most of the outage scenarios. Also, since shunts alone cannot maintain voltage magnitude within limits in some cases, therefore the proposed approach can be extended to include other resources such as generation dispatch, load shedding, and reconfiguration. So thank you very much. If you have any question, then please feel free to reach me out. Thank you.